In the past 30 years, scientists have made an incredible discovery of a new creature living deep beneath the surface of the ocean, and the name of the creature is the harp sponge. Now, if you're wondering why it took so long to come across this animal, then I might have the answer. These creatures typically hang out at a depth of roughly 11,100 feet beneath the ocean's waves. This sponge species was first discovered off the coast of California thanks to a robot that was sturdy enough to explore those crazy depths the ocean has to offer. This is no doubt an area of the planet where even the most benign-looking creatures can be potentially dangerous. But even scientists were surprised to find that this creature was more than just a sponge. Now, this might seem obvious, but the harp sponge got its name because its basic structure, referred to as a vein, is the same shape as a harp. Each vein is made up of a horizontal branch supporting several parallel vertical branches. But don't let the harp sponge's fanciful and amusing appearance or its non-intimidating name fool you. Yeah, the harp sponge is very much a deep-sea hunter. It has a unique ability to capture and envelop small animals using its rhizoids, short, thin fibers. With their help, the harp sponge clings on to the soft muddy bottom and catches tiny creatures that get swept into its branches by deep-sea currents. Uh-oh. Other sponge creatures often feed by pulling bacteria and bits of organic matter from the seawater and filtering them through their bodies. But not our harp sponge. Instead, it snatches its future meal with minuscule barbed hooks that cover each of the harp sponge's branches. Now, harp sponges prefer tiny crustaceans like crabs, crayfish, shrimps, and prawns. Once the harp sponge has one of them in its clutches, it envelops the animal in a thin membrane before slowly beginning to digest it. So, pal, what's eating you? Oh, Harpo? Too bad. Researchers believe that harp sponges use this method of feeding because there aren't enough nutrients that deep down. This makes traditional filter feeding less effective. Research has shown that the creature is still in the process of evolving. Early harp sponges, researchers found, only had 2 veins, but later, scientists discovered other harp sponges that had 6 veins. The harp sponge might have evolved this elaborate candle holder-like structure to increase its surface area. In general, harp sponges typically grow up to a length of 1 foot, but researchers have seen a creature that was 2 feet in length. The harp sponge is not only very unusual, but also beautiful to look at. See those tiny white balls on top of the branches? Now, why don't we look at some other creatures that live below the photic zone of Earth's oceans? The photic zone means the area beneath the ocean's surface that still receives some sunlight. Thanks to this, there are loads of different creatures and organisms living there. Any animal living beyond this layer qualifies as a deep-sea creature. The Tomopterus worm is a segmented worm you can find in the twilight zone of the ocean. This is the area that lies between 650 and 3,300 feet beneath the surface. These creatures are often no more than 1 inch long, but the largest of them can grow up to 1 foot. While swimming around and feeding, these worms do what researchers describe as an amazing smooth dance. That's because the creatures can swim extremely quickly and maneuver at tight angles with ease. Now, I know most people hear the word worm and think of the common earthworm, so it's quite interesting to know there's a deep-sea worm out there that never leaves the water during its entire life. Similarly, most of us try to avoid jellyfish that either rest on the sand or sit on top of the ocean waves. This isn't the case with a chrysota jelly. That's a deep-sea creature too. This beautiful jellyfish is mostly ruby red, bright orange, or electric purple. That's what helped researchers realize they had found a new species of jellyfish. The creature grows to a maximum size of 1 inch across. It has tentacles that stretch out in every direction. Now, if you come close to this jellyfish, it'll pull all these tentacles in toward its body before rapidly swimming away to avoid danger. Yes, you are dangerous. The chrysota jelly is extremely rare. You won't see it very often. You might need to borrow that deep-sea diving robot I mentioned earlier. While worms and jellyfish might seem quite harmless, this isn't the case with the Pacific viperfish. Ooh. This creature is equipped with a noticeably big mouth, like me, and the needle-like teeth inside are key to its hunting strategy. Pacific viperfish live at around 5,000 feet below the ocean surface. but they're among those numerous marine animals that migrate each night from the ocean depths toward shallower waters to dine. What's on the menu for dinner tonight? Lots of small fish and shrimp. The creature can grow up to 12 inches in length. Its two front fangs, which stick up from the fish's bottom jaw past its own eyes, are especially dramatic. When the fish unhinges its jaw, its mouth can open wide enough to engulf smaller animals, and the teeth form a cage to prevent an escape. Now, have you ever seen an underwater creature that looks like a strawberry? Trust me, it does exist. Just look at these dots on the strawberry squid. The creature has a big eye and a smaller one. You might think this unconventional pairing would be awkward and uncomfortable, but it's actually the opposite. The big left eye looks upward. It spots shadows cast by other animals in the dimly lit waters above. The eye's tubular shape helps it collect as much light as possible. On the other side of the squid's head, you can see its right eye. It's small and looks downward. This eye searches for flashes of bioluminescence produced by animals lurking in the darker waters below. Now, bioluminescence means the production and emission of light by living organisms. By the way, the squid has a nickname. And no, it's not Squiggy, although that's a great one. It's known as the cockeyed squid. This is simply due to the remarkable difference in size between its two eyes. I think I like Squiggy better, and so it goes. Since light doesn't reach the deep sea, the strawberry squid's body actually looks black. This helps the creature hide from enemies, such as sharks and dolphins. In general, the strawberry squid grows to a length of 5 inches. It typically lives around 3,000 feet below the surface, but floats to shallower waters at night. Now, the feather star is a marine creature without a backbone, but with feather-like arms that radiate from the center of its body. These creatures first appeared around 200 million years ago. Related to sea stars, they look like a flower, but if you approach them, they'll quickly swim away. But not all feather stars can swim. Many species can only crawl along the bottom of the seafloor. Like some of the other deep-sea creatures we've looked at, the feather star can adapt to its surroundings. It has a creepy ability to shed its arms, the same way some lizards can shed their tails. This also helps them escape from their enemies. Feather stars live all across the globe, from the equator to the poles, from the shallow waters on top of reefs to the deep, deep sea. Now, given that we're dealing with mysterious creatures, the name of this one is quite fitting. The swift vampire squid should be the official symbol of life in the deep sea. The animal has a dark red body, huge blue eyes, and a cloak-like web that stretches between its 8 arms. This, along with its name, may suggest that the creature is some form of a terrifying hunter. In reality, though, the vampire squid is a soft-bodied, timid creature, about the size, shape, and color of a football. It grows to roughly 12 inches in length and lives 3,000 feet below the waves. There's almost no oxygen there, but also relatively few predators. I think I'll need to decompress from this one.
The giant shark that terrorized the oceans some 20 million years ago. For 13 million years, this 60-ton beast dominated the warm waters of our planet. Though, some believe that the Meg still lives in the most remote and deepest parts of the ocean. It's a hot summer day. It seems only logical to go for a swim in the sea. You're floating on your back, completely relaxed. Your eyes are closed. Your breath is even. Water's pleasantly cool around your body. A light breeze touches your face. You feel calm enough to doze off. Suddenly, something bumps into your leg. Yanked out of your half-slumber, you begin to flail until you're face-to-face with the invisible danger. Luckily, all you spot is a couple of easily recognizable fins and cute smiley snouts. Phew, just dolphins. Guess you're lucky to meet them in the wild. These amazing creatures are so close, you can touch them. You've heard people say dolphins' skin feels rubbery, but to your mind, it's more like the inner part of a hard-boiled egg. One of the animals is so close to you that its salty smell fills your nostrils. You know, though, that dolphins don't have sweat glands. It means they don't sweat and are pretty much odorless. The smell you sense comes from the water they swim in. The largest and most ferocious predator to ever haunt the oceans, the Megalodon shark dominated the seas for centuries before coming extinct millions of years ago. However, scientists managed to discover very few remnants of the giant shark. Everything we know about the great beast we've learned thanks to fossils of its giant teeth, which are just about the size of the average human hand. A megalodon skeleton has never been discovered. Shark skeletons are made mostly of cartilage, meaning that they decompose quickly. Luckily, sharks continuously shed and regrow teeth throughout their lives. One shark can go through 40,000 teeth in a single lifetime. Scientists have managed to study different types of shark species based on their teeth alone. The megalodon shark had around 276 teeth. When they fell out, those teeth landed in the seabed where they stayed for millions of years, fossilizing. Scientists found those teeth, and they're the only real record we have of the megalodon's existence. Megalodon teeth have been discovered all over the world. It means that unlike other marine animals of its time, the megalodon was intercontinental. Even today, most sharks and marine animals tend to stick to one sea or ocean. The megalodon shark swam freely around the world, moving between tropical and subtropical waters. Megalodon teeth have been found in every continent apart from the freezing cold waters of Antarctica. When a megalodon makes a starring appearance in a movie or TV show, it's portrayed to look like a giant version of a great white shark. Scientists previously believed that the megalodon and the great white shark both descended from one common ancestor. Still, it's not true. In fact, it's more likely that the megalodon was the arch-enemy of the great white shark's ancestor, the broad-toothed mako shark. That means Megalodon wouldn't have looked so similar to the great white after all. In reality, the Megalodon would have a shorter nose than the great white, along with longer pectoral fins to give the giant shark a stockier and more threatening build. They both had an excellent sense of smell though, so even in prehistoric times, it wasn't a good idea to go swimming with a chunk of raw meat in hand. And it certainly isn't safe now. Whether the Meg's hiding somewhere in the depths, which some still believe is true, or it's gone forever, younger cousins will still be there waiting. Also, both of them like to go after big marine mammals, so they would certainly have things to do together. That is, until the Meg got moody and accidentally ate its friend. You never know. These guys had a different hunting style. Great whites prefer to dive straight towards their prey and find its softest spot, like exposed legs or underbelly. Sometimes, an entire tooth would be found embedded in a bone of some bigger animal, such as a whale. Without the main parts they use for swimming, poor sea animals were then helpless and unable to escape. Yet whales were just a smaller part of Megalodon's diet. Seals, sea cows, squids, dolphins, other sharks. The good old Meg probably wouldn't say no to some random school of smaller fish swimming into its mouth either. Nothing better than a good snack after a big tasty dinner. Even those giant turtles weren't safe with their thick shells. The Meg probably took them as a dare challenge on a daily basis. Scientists have used computer simulations to try and work out the hunting style of the ancient shark. Using this technology, scientists have discovered that the Megalodon's attack style was very different from that of modern-day sharks. Modern sharks dive straight for their prey's most vulnerable spot, for example, the soft underbelly of a seal. The Megalodon's teeth were uniquely suited to biting through tougher areas of cartilage. So, evidence suggests that a Megalodon would first chew the tougher fins of their prey, rendering them unable to swim away before launching into their final attack. Some people believe that the Megalodon is still alive today, lurking at the depths of the ocean's waters. But it's unlikely to be true. Megalodons are a warm water species, which means they would be unable to survive in the cold waters of the deep ocean. Most of the Megalodon's potential prey live in shallower waters, meaning there would be very little for the Megalodon to eat at deep sea level. Simply put, if there was an animal as big as the Megalodon still living today, we would have spotted it by now. It is unlikely that you'll run into a Meg though. The sharks, like us, preferred warm coastal waters. Deep ocean living would be too cold for the beasts, and food would be scarce. Their entire bodies would also have to evolve to avoid being squished by the enormous water pressure down there. It's unlikely they're still around, but not impossible. Some good news if you do run into one is that the shark is pretty unlikely to eat you. You are way too small a meal for the Megalodon, even if you have a couple of friends with you. This guy eats whales that are over 50 feet long. If you're having a beach party though, it's a different story. In a beach full of swimmers, The shark very well might creep up, scooping several humans into its giant mouth without even chewing. The fearsome name Megalodon comes from two Greek words, megas, meaning big, and odont, meaning tooth. Combined, they mean big tooth, and it certainly lives up to its name. Just one of its chompers is the same size as a human head. It had 276 humongous teeth in total, across 5 terrifying rows. In all of history, only a couple of saber-toothed cats and the T-Rex had consistently bigger teeth. Now that's a showdown I'd like to watch. The Megalodon vanished millions of years ago, leaving only huge teeth to be found by modern archaeologists. They literally disappeared with very few traces left. Scientists believe that over time, deep sea levels dropped and the ocean's temperature went down rapidly. Over a third of all marine life was wiped out as the oceans cooled and the number of animals at the bottom of the food chain plummeted. This had a catastrophic effect on the hungry predators at the top. Sorry guys. It became way too cold for these sun-loving sharks too, which made it difficult for them to reproduce since they gave birth in warm waters. The Megalodon is usually described as a sort of great white shark, but this is just a common myth. In fact, the ancestors of today's great white existed at the same time as the Meg, but they weren't best buddies and were even in competition with each other. The great white shark was a better hunter using its smaller size and agility to snap up the Meg's prey quickly. They were also known to eat Meg pups, who were only half their size. This didn't exactly help the whole extinction thing. While a great white was no match for an adult Meg in a head-to-head fight, they sure weren't scared of stealing their food. This only left the bigger fish and whales for the Meg, but its food supplies began to run out as whales swam to the cooler new seas. The whales adapted to prefer the colder temperatures, leaving our friend the Meg behind. The Megalodons either starved or were frozen into extinction by the Ice Age. Rather than a great white, the Megalodon is more like a modern bull shark. It had a short snout, a flat lower jaw, and huge pectoral fins to support its massive weight and size. As scary as they are, these sharks were actually caring family guys. Several Megalodon nursery areas have been discovered in Florida, Maryland, and Panama. They gave birth to their young in shallow water environments. We know this from discovering loads of tiny Megalodon teeth found in these areas. I wonder if they had nannies too.
Magma oceans, supersonic winds, scorching hot days, and instead of rain, a bunch of rocks falling on your head. Just another one of those days, huh? Astronomers recently discovered a new superplanet out there. K2 414b is an exoplanet that's around 200 light-years away and in serious need of a new name. An exoplanet is just a fancy way of saying that a planet orbits its own star in another solar system. The Earth orbits the Sun, so this planet has its own orbit party going on. So what makes K2, bunch of numbers, so scary? Picture our beautiful little blue planet Earth. Now imagine that all the volcanoes in the world suddenly erupted at the same time and lava covered the oceans and seas. Fiery hurricanes, thousands of times faster than normal, blow all over the place, 24/7. And it starts raining rocks every now and again. Rocks, like on your head. Thankfully, not in your head. This scary planet came into our lives about 2 years ago. Scientists are still studying it. So, what's a typical day like? For starters, you can forget about breathing. Oxygen decided to take a pass on this planet. You'd have to get used to sodium, silicon monoxide, and silicon dioxide, which is, as you guessed, not great. And that's just scratching the surface. Who knows what other chemicals are lying around? And yes, magma oceans. The planet's surface is covered in molten magma as far as the eye can see. This lava planet orbits really close to its star, which is why the surface is like a fireplace. The closest planets to our Sun are Mercury and Venus, but this planet's even closer. And what's even more weird is that half the planet is in constant daytime, the other half night. It's tidal locked, just like our moon is. No matter how long you stare at it, you'll never see the other side. That's why the all-day, everyday scorching fiery side is so hot and overflowing with magma oceans, while the other side's in a constant state of deep freeze. If the magma doesn't burn you, you've still got big problems, and please don't look up. It's raining rocks. On Earth, water turns to steam, rises up, becomes clouds, cools, and falls as rain. Over there, on planet Fireball, it's exactly the same, except for it's rocks, people. The planet's so hot, it vaporizes rocks. Oh, and don't forget the supersonic winds with speeds up to 3,000 miles per hour. Imagine your hat getting blown off your head at 5 times faster than an airplane. The strongest wind on Earth was the tropical cyclone Olivia that hit Australia. It was blowing at 250 miles per hour. Now imagine 12 times that. On the sunny side of the planet, you're looking at a roasting 5,000 degrees. The hottest it ever got on Earth's surface was in California, 135 degrees. It's pretty common for it to get near that temperature in the Sahara Desert, but that kind of heat's not exactly enough to make rocks evaporate. If you grew up near a desert, you already know how dry and hot it always is. But did you know that deserts can reach freezing temperatures? A desert, by definition, is a large area with little or no rainfall. That means no water vapor to keep the temperatures from going insane. In the daytime, the sun heats up the desert like an oven. But when the sun sets, the heat packs up and heads home, and it can get really cold. Some deserts have even reached minus 40 degrees at night. But wait, shouldn't deserts have snow if it's that cold? Well, some deserts have had a bit of snow here and there, but because there's no water vapor, there can't be that much snow. Just dry, freezing, sandy Sahara nights. Now, the Sahara Desert's actually not the largest desert on Earth. It's Antarctica. 5 million square miles of icy dryness, almost no people, and a whole bunch of cute penguins. Penguins technically live in a desert. Back to the Fireball planet, this time the night side. Never-ending darkness and extreme cold, about minus 330 degrees. Add in some supersonic winds? Earth's coldest? Minus 130 degrees at a research center in Antarctica. So, how does this jalapeno pepper exoplanet stack up against some of our neighbors? Well, Mars isn't exactly livable either. It's the red planet, so you'd think it'd be hot most of the time. But it's usually freezing, well, way below freezing. And if you're planning a weekend getaway to Mars, you can leave the umbrella at home. Nah, it doesn't rain rocks, and it actually hasn't rained there for millions of years. At least Mars has days and nights, and it's like Earth in other ways. Mars' equator is steamy hot, and it gets pretty cold at the north and south poles, just like Earth. Scientists even discovered old bits of carbon dioxide snow there. The entire planet is actually covered in carbon dioxide, with a splash of nitrogen here and there. Scientists even reported intense snowstorms on Mars. But because it's mostly carbon dioxide, it's not your typical snowstorm. It's more like a dry ice storm. That's the stuff they use in fog machines. Mars isn't the only place where climates are going cuckoo. Jupiter's famous for its gigantic storms. Not like the ones we know on Earth. I'm talking about storms that last for centuries. The Great Red Spot on Jupiter is actually a 400-year-old storm, and you could fit 4 whole Earths inside of it. So it's been around for a while, but it's nowhere near as intense as the storms on K2. Venus also has intense rain, but it's not made of rocks. It's sort of worse. It rains sulfuric acid. That stuff can give you severe skin burns and rip nasty holes through your umbrella. Venus's atmosphere is filled with carbon dioxide, which acts like a net to trap in the sun's radiation, and it's insanely hot. No magma oceans, though. Mercury is the closest planet to the sun and doesn't even have an atmosphere. That means no storms, clouds, rain, wind, whatever. Mercury is kind of like a desert here on Earth. No water vapor and no rainfall. That means temperatures shoot up during the day and drop like crazy at night. The K2 exoplanets, like the most extreme parts of all of our solar system, all rolled into one scary planet. But we're not headed there anytime soon. We haven't even been to Mars yet. That's all way off in the future, and 200 light years is a really long travel time. If we're going to move anywhere anytime soon, we'll probably want to set up camp on the moon. No magma oceans, no warp speed winds, nice temperatures. So, where would we even start? Well, the main issue is that drones and remote control robots are getting more and more advanced. It's way cheaper to send them over to map out the moon for us while we're safe here on Earth. And if we ever want to begin space exploration for real, we'd need a proper space base. And what better place than our little shiny moon? So, why do we even study those far-off planets? What's the point? Well, planets are like people. They're all different ages and live in all different places. The more of them we study, the more we can understand why there's life, aka us, on Earth and not on any other planet so far. When we see crazy new planets, we get crazy new ideas, which can turn into awesome inventions that make our lives easier. Even just going into space gives us new ideas. Scratch-proof lenses, some firefighting equipment, water filtration systems, wireless headsets, invisible braces, that tiny vacuum you use to clean those crumbs in from between your couch cushions, they were all invented to help astronauts work better in space. And now they make our lives better every day. Maybe we'll figure out a new energy source someday, thanks to a far-off planet or star. Or we might discover a new compound that will make our buildings stronger or more energy efficient.